Welcome to the Earth Science Classroom. This video is all about barrier islands. Now, we're looking at how these amazing areas form and the different theories of how they form and also where they can be found around the world. All right, so join me now. So what is a barrier island? So a barrier island, or barrier basically means that something is going to stop, there's an object or an obstacle in the way of, in this case, the ocean. And the island depicts it there as water on all sides, basically. There's a piece of land and then water on the outside. So you can see this from this video. Just pause it for a second. You'll see on the right-hand side, the far right, you have the, in this case, the Atlantic Ocean. I'm on a sand dune, actually just south of Nag's Head. There's a body lighthouse right there, and the Atlantic Ocean, and the beautiful beach for the Outer Banks is right here. And if you go across this very thin, narrow stretch of pretty much a mixture of sand, unconsolidated material that has accumulated over time, and over here to the far left, you'll see actually the sound and the very shallow area of water that is basically between this barrier island in the Atlantic Ocean and the coastline, the mainland, in this case, North Carolina. It's all North Carolina, but the mainland is over here to the left. So a barrier island is a stretch of narrow, elongated land that's mostly made up with sand and other unconsolidated material that has been basically deposited at this location through a complex and a mixture of both longshore drift currents, wave action, tidal action or tidal currents, and wind. So it's important you need these different factors there to create these beautiful barrier islands. Now, the Outer Banks is a populated stretch of land. Some barrier islands are completely uninhabited by humans, and they're just very straightforward sand dunes or some dune ridge systems with some basic vegetation and dune vegetation, as you can see right here in this video. And if we just scroll around, you'll see that beautiful, nice mixture of wave and tidal dominated beach. And to the left here, this area of water here is the Croatan Sound, which also links up to the Pamlico Sound towards the south. And this island over here is actually Roanoke Island, which is also famous in history for the first English settlers to America and the Americas. And yeah, it's a beautiful, very shallow area between the Barrier Island and the North Carolina coastline, the inland. Take this very, very advanced, very technical drawing here on the left-hand side. We have a very basic schematic of a barrier island. So we have two areas of water. We have the ocean, and we have the creek, the sound, or other terms that can be used for it, bay as well. Could also form part of a ria, which is a drowned river valley. If it's in the north with a glacial valley, then it's a fjord. But this area here, obviously, is the ocean in terms of the Outer Banks would be the Atlantic Ocean, and these terms here are linked to, there we go, this area of water between the mainland. So this would be the mainland, and this would be the set of barrier islands right here. So I have left, on purpose, have a separation, an area within the barrier island system where the water can actually flow through from the ocean into the creek, bay, or sound. And this is a tidal inlet. It's an area where the tidal currents, now this these barrier islands need a mixture of a small tidal range and a large amount of wave dominated beaches, and obviously a very large amount of sediment that is available to use to build up these islands. So there are much more different terms we can get into, but I'll get into that later on in the video. But again, this barrier island is created through a very complex mixture over a long period of time, thousands of years, of both wave action, hydraulic action caused by the waves, wind and varying winds, and obviously causing the wind is going to create the wave action and the swell over the large fetch. Longshore currents, which is the basically the movement of water and sediment parallel to the beach through different directions of swell. Sea level changes, which again comes very closely linked to the ice ages. Why? Because when you form glaciers or glaciers, you then use a lot of the water, and the sea level can drop when the glaciers or glaciers melt and retreat back north. Then obviously the water is going to go back into the ocean eventually through the water cycle, and the sea level is going to increase or rise up. So coastlines will change over the course of 10 to 20,000 years, according to climate cycles, patterns of glaciers, interglacial periods, cold periods, and these flat, very gentle sloping coastal areas like the Atlantic Ocean, which is a passive margin, like the Gulf of Mexico, again, a small sea that is, again, very gentle coastlines. You're going to have a very conducive area to form these barrier islands, again, over a long period of time. So gentle slopes. Very small to medium tidal range in a matter of feet, nothing too large, again, and a very wave-dominated beach. And obviously, you need a lot of available sediment, a lot of available sand. Nothing to build with. You can't build this huge island up, and could get just basically a bunch of shoals, which is the same thing, just underwater. It's not exposed above the sea level, and it's just underwater. But you need a lot of sediment to build it up above the ocean. So in general, and I love a good fact, there are around 2,100 barrier islands around the world. And the longest is in Texas. It's Padre Island, which is very, very long. It's a 113-mile continuous island, which is crazy long. 15% of the world's coastline is covered with these barrier islands, some small, some large, like in Texas. Some that are populated, some aren't. Some are just above the water. Some are, 10s, 20 feet above the water. There's around 405 in the States alone. And the best thing about these beautiful coastline environments is you can link them into different kind of topics. You can diversify your lesson and go into the anthropology, how humans settled in these areas and used the estuaries and for fishing, obviously for growing crops and the fertile soils. The barrier islands would basically block a lot of storms and give protection, not only for the animals, but also for the humans that settled there. You can look at the different habitats and breeding grounds that these beautiful creeks and inlets and sounds and lagoons provide as part of the biome and biodiversity in these hotspots. Look at the environmental science aspects and the impacts of humans on the environment in terms of pollution, in terms of population, and basically building on these islands that are naturally dynamic and move with the tides, with the waves, with the wind, and over a long period of time. So there are two types of barrier islands. So type 1 and type 2. Type 1 is wave dominated. So areas on the coastlines that have very small, if not basically nothing in terms of tidal range, intertidal zones, and it's pretty much wave dominated. And what you'll have is certain characteristics. You'll have a very obviously low tidal energy. You have a lot of washover fans, which we'll get to in a second, and they're very long and they're very elongated. They're very stretched, they're very long, very narrow. Okay, you can also argue that would be the Outer Banks, as well as places like some Texas Barrier Islands, like Padre Island, is wave dominated. Next one would be mixed energy. So you've got a mixture of both wave energy, obviously, because it's going to build up the sediment and build up the barrier islands, and you've got the tidal energy, that consistent pattern cycle of tides, the neap, the spring, high and low tides, whether it's semi-diurnal or diurnal or 2 a day or 1 a day of the high tides, low tides, but you have a mixture of this energy. So it's going to change the amount of deposition. And it's going to change the shape. So wave dominated would be more long, narrow, and elongated. This would be more like teardrop shaped, more wider, more not as long, and wider and shorter, with a lot more tidal inlets. So gaps in between the islands, like this. And the tides would flow in from the ocean to that area of water between the barrier islands and the coastline. Whereas the wave dominated, there will be more continuous stretch of longer things. There'll still be some tidal inlets, but there won't be as many as the mixed energy. So how do these barrier islands form? So there's three theories of formation. There is the offshore bar theory, the spit accretion theory, and the submergence theory. Now, all these theories are good, and they are contested and argued scientifically of how different parts or different areas of barrier islands in the world are formed. Now, some might argue that one theory works better for the Outer Banks, whereas one theory works better for the Gulf of Mexico and Padre Island, and one theory works for a different area in a different part of the world. However, those three theories are, the holistic view on how they form. But bear in mind, you need the three things in a very complex and delicate balance, which is the sea level changes and the fluctuations, obviously the ice ages over tens and 20,000 year cycles, the wave action, the waves, the dominated beaches of waves, and obviously the sediment, the material that builds these islands up from the ocean floor, from the seabed up through shoals, and obviously breaching the water surface and creating these islands, these barrier islands. And this balance is created. Now, obviously, time is a large factor in this, because they, are assumed to grow and build over thousands of years. These aren't a very fast moving cycle. However, in terms of geologic time, they are fast, because we're talking about thousands of years and not millions or billions of years. So in terms of that, they are pretty quick. But in humans' perception of time, obviously they're kind of slow, and they are dynamic. So they're always changing. Storms and different areas can affect sea level changes. You can have a large effect on these islands and the shape, the elevation, and the amount of material that is deposited or taken away by the ocean as well. So the first theory of how they form is the offshore bar theory. Now, this came about in 1845 by a French geologist by the name of Jean-Baptiste Elie de Beaumont. He also had a longer name, as Jean-Baptiste Armand Louis Léonce Elie de Beaumont. Again, my French just butchered that completely. Sorry if you're listening in France, I apologize. And he basically suggested that the bar, basically, which is a accumulation of sediments, mostly sand, builds up from the ocean floor. So here's my ocean, here is my beach, here is my ocean floor, and then here is my bar or shoal. And as the wave action comes in and picks up the sediment, it's going to drop more and more sediment onto this area, because when it gets shallower in terms of the depth, it's going to lose energy, deposit more sand on that exact location, and over time this shoal or bar is going to grow and eventually pop its head above the ocean surface and start to form the barrier island. At that point, it's going to separate this part of the water, and it's going to have some accumulation here, some washover fans. So eventually, and it gets shallower and shallower, so you get more and more deposition of this, and it gets shallower and shallower over time to maybe a few feet, and that creates your lagoon or creek or sound or bay area. And it also would dictate and change vegetation. You might get some tidal flats, you might get some salt marshes, some tidal, some very flat area, and you get the different types of vegetation start to grow there. So that is the offshore bar theory. So the next theory is the spit accretion theory, which was in 1885 by an American geologist called Grove Carl Gilbert, also is related to G.K. Gilbert. So the spit is, here's my coastline and here's my headland, and it goes into a bay like that. And let's say the ocean waves are there, so we have this longshore current, we have our beach right here. All right. Now, what's going to happen is a spit is a deposition or deposited sand, basically when there's a change in the direction of the coastline, according to the ocean and the waves and the wave action and the longshore current, which is going this way, taking sediment along the beach parallel, what's going to happen is the sand will be basically picked up here and moved by the swash and backwash in this kind of like direction, and it's going to come like here. Now, it could sometimes keep going around the headland, which is right here, right there, and could go around, but generally it just keeps on in like more of a straight line pattern and deposits it on the edge right here. So this area of water or ocean or near the shoreline, the beach will be extended out into the water this way, and this will create a spit. And there would be like obviously some more back here and some washover maybe, but you might get a shallower area over here, but then the main water comes like through here. Depends on the depth of the seabed right there. But the spit would develop off the coastline. So this theory by Gilbert was that the spit would get larger and larger and larger, and over the course of thousands of years, it actually come out into the ocean deeper and deeper and deeper, out like this. And let's say you have a 1 in 100-year storm, very large hurricane, or some sort of low pressure system that comes through and then just obliterates this part of the spit right here. Let's just erase that. There we go. And it's going to separate the coastline spit to the larger spit that's formed out in the ocean. And you'd get the water flowing this way again, and you'd start, again, accumulation of, because this is now a shoal or ridge that's above the small island, you would then get basically the growth of a new barrier island right here. Then a few years, around 5 years later, a American geologist by the name of William John McGee suggested that these coastlines, being passive margin, being very gentle slopes, and the cycle or pattern of ice ages and glacial ice melting and forming, you might get an area of coastline which is then submerged, and that would form the barrier islands. So if you have your so you have your coastline, right? So say here's my coastline, all right, and here's my little islands there. Now, what happens is you get, here's the ocean right there. Now, obviously, this would be during an ice age. Let's say glacial maxima, let's say around 20,000 years ago, when the good old Native Americans came over the frozen land bridge of the Bering Strait from Asia on that time, and you got lower sea levels. So lower sea levels are lower. Still the same kind of shape and gradient profile of the beach as you'd find, and obviously you have this towards inland there. You might have an accumulation like a ridge or a sand dune already present there because of the wave action, you know, and the various storms that come through, but you have a generally lower sea level, so it's lower. Now, obviously, submergence means that the sea level has to come up, has to rise. Now, this is well discussed in literature that this is the most prominent way of forming the barrier islands, especially on the east coast of the Atlantic Ocean, of America, and the Gulf, where you have this very passive, gentle slope, but you have the corresponding growth of around 5,000 to 7,000 years ago, when the sea level rose rapidly, actually over between 15 to 12,000 years ago. It went basically rise really quickly by a few centimeters per year, and over 100 meters of increase since the ice started to melt. So up goes the ocean sea level. There's new sea level. Now, as time progressed to 5,000 to 7,000 years ago, that obviously the melting had been pretty much completed, and the sea level would only fluctuate by a few millimeters per year, allowing that consistency in the coastline to form the barrier islands. Now, you might still get a combination of the sandbar offshore bar accretion theory, but you have this submergence where now you have a submerged area, and the accretion of the sandbar or the shoal or the increase in the already existing barrier island a little bit to form this situation. So you have, again, the filling in of sediment. It's shallower and shallower and shallower, this lagoon right here, and you'd have the ocean level higher, and this would be the new inland coastline. Now, this is the, again, most people would agree that this is the most agreed upon formation theory. However, there is other ways as well, as discussed with the spit accretion and offshore bar. So, quick review: definition of a barrier island is a narrow, elongated stretch of land which is parallel to the beach, parallel to the coastline, which separates the ocean from the small area of water, usually a lagoon or a creek or a sound that is generally shallow and calm and low tidal ranges. The coastline needs to be gentle sloping, generally a passive margin, and it takes thousands of years to develop. So there's a balance between the sediment, the waves, and the fluctuating or small range of sea level changes over time, which will allow the barrier island to develop. And the two types are wave versus the mixed types. Again, will just dictate the shape and the size of those barrier islands. And the three theories of how they formed, dating between 1845 and 1890, between the three scientists, and looking at different ways between the spit accretion, the offshore bar theory, and the most commonly used in literature is the submergence theory of the change in sea level. Thank you so much for listening. If you didn't subscribe to the channel, please do so. Leave a comment. Always nice to chat with the people that are watching the videos, and see you soon.